Institution Mobile, quality e-learning experience on the go.
Hydrogen. Hydrogen is the only non-metal that appears, of course, in group 1. It is metal and at the same time it is non-metal, basically because of its single electron, and in that particular place where it has the electron, it's supposed to have 2 electrons, so it can act as both a metal or a non-metal. Now, hydrogen production of hydrogen, it can be prepared by the by introducing metals into acids, especially sulfuric acid, and of course hydrogen gas will be produced. What are the properties of hydrogen? Hydrogen, it is colorless, odorless, tasteless. It is gas in stable state at room temperature, and it is lightest gas, lighter than air. It is explosive in nature. How do we test for hydrogen? To test for hydrogen, all you just need to do is expose the gas to oxygen or to air. It gives a pop sound. Explosive, it explodes with a pop sound, the quick squeak pop sound. The use of hydrogen. Hydrogen is used as a fuel. It's used in making of ammonia, which is very, very useful in making of fertilizers. It's used in the production of plastics, and it's also used in turning vegetable oils into margarine. Properties of halogens. Halogens are elements of the group 7. They are the group 7 elements, and they consist of the fluorine, bromine, iodine, artesunate. Fluorine, chlorine, bromine, iodine, majorly. Now, all of them are they exist in diatomic molecules in nature, and of course, they have 7 electrons in their outermost shell. Basically, their properties: fluorine is yellow in appearance, chlorine green, bromine orange, iodine gray black, and artesunate is black. In the states, fluorine exists as in nature as a gas, chlorine as a gas, bromine as a liquid, iodine and artesunate as solid. Yes, that's on the slide. You can see on the slide you can see showing their increasing molecular sizes, their increasing densities, and their rate of reactivity. Reactions in which halogens generally involve themselves in: of course, they react with alkali metals, they react with hydrogen, they react with alkali metals to produce salts, they react with hydrogen to produce acids, they react with water to produce 2 acids, and they also act as oxidizing agents. Chlorine. Chlorine is picked out of the group 7 elements. It is produced in the laboratory by exposing manganese 4 oxide to hydrochloric acid. That's an oxidation process, and chlorine gas will be liberated in the process. Testing for chlorine. Chlorine is acidic in nature, so all you just need to do is use a damp blue litmus paper. Chlorine turns it pink because it bleaches the litmus paper, which would have been red, and of course, it also turns starch iodide paper black. Chlorine oxide is a gas produced. It's also a gas produced when either by reacting hydrogen with chlorine directly, or by taking it through reacting hydrochloric common salts, stable salts, that's sodium hydroxide, sodium oxide, sodium carbon.
Must you take this topic?
It's the longest topic in the whole thing, but it's the one that made me sit down all day long.
You can take it too, no problem. But the final is on the system.
There's no point.
That's what I was thinking. It's too long, 1. 2, it's giving you a tough time. Am I lying? I'm not lying.
It's not really giving me a tough time.
You feel down now.
If feel you can do it, continue.
It's not like it's limit of time, it's just that I'm trying
Just paraphrase it, don't.
I'm trying to compress everything.
Make it short.
Hydrogen chloride. Hydrogen chloride is a particular gas. It has a chalky smell. It is acidic in nature. It is an antiperspirant. It is a precipitating agent and an oxidizing agent. It dissolves in water. It dissolves readily in water to produce the hydrochloric acid. To test it, this is reacted. All you just need to do is add a small amount of it to ammonia. It produces the ammonium salt, and with the silver trioxonitrate 5, it precipitates out the silver as silver chloride. It is used in the synthesis of chloroethane for making plastics. It's used in the manufacturing of dyes. It's used to remove oxides from metals, to remove oxygen from metals, and also is used in the preparation, analyzing, and testing of other compounds. Oxygen and its compounds. Oxygen is majorly produced in the laboratory by the decomposition of potassium trioxocarbonate 5. Physical properties of oxygen includes the fact that it is a colorless, odorless, tasteless gas, diatomic in nature. It is neutral to litmus, soluble in water, slightly soluble water, denser than air. It liquefies at minus 183 degrees Celsius and solidifies at minus 225 degrees Celsius. Oxygen reacts with most metals to form basic oxides or amphoteric oxides. It reacts with non-metals to form acidic anhydrides. It reacts with most compounds, or at least it burns most of them. To test for oxygen, take a dying splinter and insert it in a test tube containing oxygen. The dying splinter would reignite to rekindle because oxygen supports burning. Ozone is the most uncommon form of oxygen. It is a triatomic allotrope of oxygen, and ozone is very, very important because it is what protects us from the radioactive rays from the sun, and it is a pale blue gas. It is also responsible for the coloration of the sky. It's a bleaching agent, and it is used as a disinfectant in water sewage purification. Hydrogen peroxide is also a pale blue sorbic liquid. It is a reducing agent. It dissolves readily in water. It's a weak acid, and it decomposes and boils at 150 degrees Celsius. It freezes at minus 0.9 degrees Celsius. Hydrogen peroxide is used as an antiseptic. It's used as a bleaching agent at the same time. It decomposes also in the presence of light. So hydrogen peroxide is always stored in brown bottles and well covered, hidden from the presence of light.
Very money, power bank.
I didn't use the press.
They oppress me as I sit down here so like this.
Okay, let us roll for the last time. I'm not finishing it up.
Sulfur and its compound. Sulfur is a solid yellow non-metal, insoluble in water, terrible conductor of heat and electricity. It melts at 119 degrees Celsius, boils at 444 degrees Celsius. That's three allotrophic forms. These are the aerobic sulfur, the monoclinic sulfur, and the amorphous sulfur. Amorphous sulfur does not have any irregular shape. It is pale yellow in color. Aerobic sulfur is a stable sulfur that we see at temperatures below 96 degrees Celsius. It is octahedral in shape, and it is bright yellow in color. Monoclinic sulfur also is stable between 96 and 119 degrees Celsius. It is dense. It's less dense than the aerobic sulfur. Chemical properties of sulfur. Sulfur forms sulfides with metals. It reacts with oxygen to produce either sulfur 4 oxide or sulfur 6 oxide, which is of course in excess oxygen. It reacts with hydrogen to produce sulfur hydrogen sulfide, reacts with carbon, and it's an oxidizing agent. It reacts with alt alkali as well. Sulfur is used in the production of sulfur oxide, vulcanization of rubber. It's used as fungicide, as insecticide, also as bleaching agent. Hydrogen sulfide is one of the volcanic gases that are found, and that's where it is found in nature, in volcanoes, and it can be easily liquefied. It can be produced in a laboratory by reacting iron sulfide with diluted acids, preferably hydrochloric acid. Physical properties: it is colorless with a repulsive smell. It is poisonous. It is denser than air, moderately soluble in water, and when it mixes in water, it forms a weak acid, triazosulfate acid, and it burns with a blue flame. It's acidic in nature. Chemical properties: it's a precipitating agent, reacts with oxygen to produce water, and of course, it is a reducing agent. To test for the presence of hydrogen sulfide, put moist lead triazonitrate 5 in the place where it is. It turns the paper to black, and hydrogen sulfide is used in the analysis of most ores and metals. Sulfur oxide is a colorless, poisonous gas with a burning, irritating smell. It is very, very soluble in water, denser than air, and easily liquefies as well. It's acidic in nature. It's a reducing agent. It bleaches, and it also acts sometimes as an oxidizing agent. It is the only compound that can act as both reducing and as an oxidizing agent. It reacts with metallic oxide to form salt and water, and reacts with oxygen in the presence of vanadium to produce sulfur 6 oxide. It is used in the making of the triazosulfate 6 acid. It is also used as fumigant. It's used as bleach, and also as a preservative and as coolant in its liquid form. Sulfur oxide has a boiling temperature of 45 degrees Celsius. It mixes readily with water to form the H2SO4, that is the tetraoxosulfate 6 acid. It's acidic in nature. It exists as a needle-shaped crystals at room temperature. Talking about the acids formed by sulfur, we have triazosulfate 4 acid, a weak acid, which of course is produced by sulfur oxide dissolving in water. It is odorless, it is colorless, and it is very, very, very unstable. On exposure to air, it produces tetraoxosulfate 6 acids. Tetraoxosulfate acid is colorless, is viscous. It has affinity for water. It absorbs moisture from air. To dissolve itself, and in its absorption of water, in its absorption of moisture from air, you do not see the moisture on it. That's how we know hygroscopic substances. It is used as a drying agent. It is a dehydrogen agent. It displaces other acids from their salts. It's an oxidizing agent as well. It reacts as an acid. It reacts with metals to produce salt and liberate hydrogen, reacts with bases to produce acids, salt and water, also reacts with trioxocarbonate to produce salt, water, and carbon dioxide, that's carbon 4 oxide. It is used for making fertilizers, it's used in paint pigment making, it's used for pairing other chemicals, and as drying agents, also in making of batteries. Nitrogen gas is very, very abundant in air. It is a colorless, odorless, tasteless, diatomic gas. Soluble in water, slightly soluble in water. Only 2 parts of it will mix with 100 mils of water at room temperature. Boils at minus 192 degrees Celsius and melts at minus 210 degrees Celsius. It has 3 valence electrons in its outermost shell, and of course reacts with hydrogen to produce ammonia. Ammonia is very, very important in production of fertilizers. In atmosphere, nitrogen helps to minimize the effect of oxygen in burning and corrosion. Ammonia is colorless, choking gas. It's poisonous if consumed in large quantity. It is alkalinic in nature. It's a reducing agent. It liberates oxygen. It reacts with oxygen to liberate nitrogen, and it reacts as a base as well as it's a precipitating agent. To test for its presence, it turns red litmus paper blue and creates white fumes in the presence of hydrochloric acid. Trioxonitrate 4 acids is a fuming liquid with sharp choking smell, colorless when pure, and starts to change towards yellow when it absorbs impurities such as water. It is unstable. It tends to decompose in the presence of light, especially. It decomposes slowly at room temperature in presence of light and yields nitrogen, 4-oxide gas, and oxygen at the end of its decomposition. It is used for making drugs and fertilizers, explosives, dyes, and used as fuels, used as solvents, and many more. Carbon is freely existing in nature in 2 solid forms, either as diamond, which is a very hard, the hardest substance known. It can also appear as graphite, which is also a very soft substance. Diamond is hardest substance known, non-conductor of electricity and heat, very, very high melting point. It has a octahedral structure, colorless, transparent, while graphite, practically the opposite. It has a crystalline structure, good conductor of electricity and heat, lower melting point compared to diamond, soft, and it has a dull black look. Generally, most carbon substances are looking black or gray, except for diamond, which has a transparent look. Now, diamonds, of course, used for cutting art, used in tools, used as a cutting tool, is also worn as a jewelry, while graphite is used as a lubricant, used in making electrodes, used in making pencils, dye for paint, and alloying of metals, and many other things like that. Carbon bonds in the presence of air, in the presence of oxygen, to produce 2 gases, carbon dioxide and carbon monoxide, carbon 2 oxide and carbon 4 oxides. And carbon also reacts with other metals to form very, very stable metals. Even though carbon usually do not react, it is very, very it does not always react with many compounds. It reacts only with selected compounds. Now, carbon 4 oxide is an odorless, colorless gas with a sharp, refreshing taste, denser than air, soluble in water, to form the H2CO3, which is acidic. Of course, it is an acidic gas, and when it easily liquefies and solidifies at -78 degrees Celsius. Solidifies at -78 degrees Celsius to form what is known as the dry ice, which is a white solid. It reacts with alkalis to produce trioxonitrates and trioxocarbonates, of course, and also it reacts. It's when carbon is burnt in limited air, of course. When carbon is burned in excess air, rather, it produces carbon 4 oxide. To test for its presence, you bubble it through lime water, which is calcium hydroxide, and it produces a milky solution. The clear solution quickly turns cloudy, turns milky, because of the instability, because of the insoluble calcium trioxocarbonate 5 that is being produced. It is used for making fire extinguishers for making other compounds used in beverages, in medicines, things that produce efflorescence. Quickly, let's talk about carbon 2 oxide. Carbon 2 oxide is an odorless, colorless, tasteless gas, insoluble in water, neutral to litmus, then slightly denser than air, is a reducing agent, and when added to test for its presence, when added to lime water as well, that's calcium hydroxide, when added to it, it starts with a burning blue flame and then turns milky. That's a distinguishing feature, the burning blue flame. Now, carbon 2 oxide is very important in making of producer gas and water gas. These two gases are very, very essential in making of very high powerful fuels.
Fusion Mobile, quality e-learning experience on the go.